let's say the problem solver itself, it's pretty, like, it's not easy, but like as in it's easy with the constraints, but it has a great follow-ups and you will just learn a lot. Cool. Let's see, we have an image smoother. Basically an image smoother is a filter of size 3x3 that has been applied to each of the cells of an image by rounding down the average of the cells and the 8 surrounding cells. So I'll just indirectly tell you what we have to do is, we have this image given to us, we have to convert this image to a new matrix. Basically we have this input matrix given, we have to convert this to a new matrix. Now the new matrix values will be nothing but if I have this value, so it will be the average of all the values surrounding it plus this value. So you can see I have 8 values surrounding it, so I will have the sum of all these 8 plus this value, so it will have the sum of all the values upon the count, because average is sum upon the count. For example, if I ask you what for this specific value, what is the average, so you will just count all these surrounding values plus him, so the sum will be 2 plus 7 plus 6 plus 1, count will be 4. And the same goes for this value right here. You will take the sum of 20, 19, 24 and 25 and the count will be 4. You will not count the outside area, you will only count what is inside. So you just have to build a new matrix out of it. That's it. That's the only thing which you have to do, which means you have to just smoothen this input matrix. Now with the question itself, the first obvious thing is you will make a new matrix, and what you can do is you can just iterate on all of the inputs. You will iterate on all of the inputs. Very simple, that you have this as a cell, you will just go on from this cell to this cell. Now we'll see what this cell to this cell means, but I will just go on to all these 9 cells. Possible, because again it can be possible that it goes out of bounds. It is possible that it goes out of bounds, so it's possible that it goes out of bounds. So we'll just make sure that okay, we also have that if condition, that if it is going out of bounds, and if not, then we'll just take the sum and we'll also maintain the count, and thus we'll just simply replace in the new matrix, because for sure we will need to have maintained the input itself. So in the new matrix we will just replace these values. So ultimately this was the question for us. So straight method 1 which we could get is, for this specific I comma j, I go from I minus 1 j minus 1 to I plus 1 j plus 1. Simple for loop from here to here it will go, and in this it will go on to all the loops. So basically I can just have a x as a variable which will go on from I minus 1 to I plus 1, and y will go on from j minus 1 to j plus 1. And with this you can actually go on and iterate on all the values of like all these cells. And again this is I am iterating, but I have to again go and check for if condition, that if my x lies between 0 and n m and my y lies between 0 and n. With this I can just simply go on all the cells, just have to check these 9 cells, in the worst case these 9 cells, and ultimately I'll get my answer. So you will see the time complexity will be O of 9 into n into m, because n into m is the number of cells, 9 times for every cell in the worst case, and for sure 9 can go away because it's just constant. Space will also be O of m into n, because you know that you are using an extra space just to make a new matrix, and that is always good practice to not modify the input matrix until unless it is asked or you are asked to do so. So as you can see, again we wanted to have typed, but nothing, as in like if I cannot show you, but yeah, see, like nothing in this is okay, this is not working, but yeah, nothing in that is working. So unfortunately we cannot, but cool. What this is, yeah, so I just got in my m and the n, and then I just have a new array called as smoothen image, or new matrix which actually will contain the smoothen values. So I just iterated on all of my cells, I n j, all of my cells. I will maintain the sum and the count for every cell. Now for every cell I told you I'll go on from I minus 1 I plus 1 to j minus 1 j plus 1, which means I will go on to all of these 9 cells. Now as I was going on to all these 9 cells, I told you you also have to verify if it is inside your matrix or not. So just have a quick verification if it's inside the matrix or not. If it is inside, please add its corresponding value in the sum, and for sure increase the count by 1. Ultimately, when for this specific cell I comma j, this entire thing, in the worst case 9 cells are seen, then, and for sure 9 cells, and this one cell itself, So this 9 cells, all these 9 cells are seen in the worst case. Again, I'm good. I can just say for this smoothen image I comma j, the answer is sum by count, which is the average for this particular cell I comma j, and ultimately do this for all the cells I comma j and ultimately return the smoothen image. With this you will just get the time and spaces of m into n. Now the interviewer asks you, sir, can you please optimize it? Time you cannot optimize, because for sure you will have to go to every cell just to get its average value. So this is one thing which you cannot even think of optimizing. The only thing which you can think of optimizing is your space, but for that you will have to not make another matrix. So the first question you will ask the interviewer is, sir, can I do in place operation, which means can I modify the input matrix? Although you will say to him that okay sir, it's not a good practice to modify the input matrix, but still, are we wanting to modify the input matrix? That is what we can ask. He will say yeah, you have to modify and get the proper answer. Okay, now my task is to reduce the space. Now if I just look back at what the operation which we were doing earlier was, when we were making a new matrix, let's imagine that it was our old matrix, let's imagine it is our new matrix. Now with this, what happened was, if I am applying an operation on this cell, then ultimately it will go and try to check for all these cell values, right? I just wanted to have all these cell values as correct, but as I am going on, and if I just try to think of doing an in place operation, so I will be modifying these cells. When I will be at this yellow cell, I would have modified all the red cross cells. I would have already modified that. So if I would go and check, okay, for this yellow cell values, give me all these values sum, you will see that all these red cross, these blue red cross values are already modified, and I did not wanted that. So ultimately my aim was, okay, I did not wanted that, which means I'm only concerned about just one row above me, and it should not be modified while I'm calculating my yellow cell value. Just the row above me, it should not be modified. So the one obvious thing is, you are only concerned about one row. Why not just take a copy of that one row before modifying it? So I'll just do simple one thing. I'll take this copy of this above row. I'll take this copy of this above row named as, let's say, previous row. So when I will be using, I will be calculating the value for this yellow cell, I will go to this blue cell, this blue cell, this blue cell, this blue cell. It is giving me the correct values, and from this previous row, I will go on to these cells from this previous row, because it has stored the copy before even modifying the value. But then you will ask, bhaiya, what about this cell? This is already modified. Yeah, great. So for this also, what you will have to do is, one way is you will have to maintain a copy of this row also. So let's say this is my current row, so I will maintain a copy of my current row also. So with this copy of current row, what I'll do, I would know that okay, the original value I can get it from the current row. So I know one thing, that I will maintain my previous row and current row. With these two rows only, with these two rows as the extra space only, I will be able to modify my input matrix itself with the correct values. For example, again, if I just do a recap, so I will have a previous row, I will have a current row. Now current row just indicates that okay, I am right now starting off with this specific row, so this is the current row, and it will always be having values before even modifying the current row. So I will assign my current row as image of I, because image is the matrix name is image, this matrix name is image. So I will assign image of I, and this is the ith row. So I'll assign image of I to this current row before modifying my image. Now again, I'll just modify my image of I. Now when I will go on to the next ith row, firstly I'll say, bro, your previous row will be the current row. So now my previous row, as you can see, the current row was here, so the previous row will come here. So basically now I just assign my current row to previous row, so that previous row will have previous rows correct values or original values, and again current row I will assign before starting to modify the current row. So current row will have the values before modifying the current row. Now I will start modifying the current row, which is the image of I. I will modify the image of I, and my original values are stored in previous row and only current row. So with these two rows only, I will be able to solve it. Now, how I will do it? For this cell, let's say I want the values. I want the 9 values. I want the bottom values. I want the right value. I want the previous value. I want the like top values, right? So what I'll do, I can get this top values from my previous row, because previous row is containing original values. I can get this left value from my current row. So if let's say it is I comma j, so I know previous row is an array, so I can go to previous row of j minus 1, previous row of j, and previous row of j plus 1. This will have previous row original value. For the left one, I can just simply go to current row of j minus 1. For the current value, I can itself get the current value, which is image of I comma j, image of I comma j. For this next value, I can go to image of I comma j plus 1, and for the bottom values, again image of I plus 1 comma j, I plus 1 comma j minus 1, I plus 1 comma j plus 1. So with this, you can get all the 9 original values, and then you can simply modify the current value. So with this, you will always be having previous row and current row as just 2 extra rows, which will use 2 extra spaces. Now, although this will have the time of O of m into n, because that is what we cannot even think of modifying, and space is just O of n. So your space has reduced from O of m into n to O of n. Many people I have seen will jump straight off to O of 1 solution, which is not intuitive, as in like you can just think of, but it will not show you that you can think of in every direction. The next step is to reduce a space a little bit by giving a solution of O of n. Again, that is a O of n into 2 solution, because you will see you are using 2. Again, you can say, interviewer, that sir, I can do a bit more modification in this by just saying that I just need a previous row. And rather than current row, I can just take a previous value, because I'm not concerned about these values. I'm concerned about just previous value. So rather than 2 rows of size n, I can take 1 row of size n and 1 variable, and that will also work. But that is a follow-up for you guys, that give me a code, although the space will again be O of n. It's just that earlier it was O of n into 2, and now it will be O of n itself. But the follow for you is comment down the code for space of exactly O of n. I will show you right now O of n into 2, which means using previous row and current row, because that is much more like to showcase, it's much more a simple code. But again, exactly everything is same. N, m and n, we have got it. We don't need this variable. We just need a previous row, we just need a current row, and again we don't need the previous value, because that would be required if we are using just 1 row. But now we plan to use 2 rows. Previous row and current row. So before even starting off with my image of I row, I assign that to my current row, because as soon as the loop will end, I will assign previous row to the current row as soon as loop will end. Now I will actually go on to my all of the values, because for a cell I need its top values, I need its left, like I need its previous neighbor, I need its next neighbor, and I need its bottom values, right? That is I need for I comma j. So I went on to, and again this is the sum and count which I want to initialize. I will go on to all the bottom neighbors. So simply saying if I plus 1 is less than m, and if I have this j values, like just saying okay, if it is in the bounds, just simply go it. If I can go to this specific cell, go to this cell. I can for sure go to the cell, because I plus 1 is less than m, so I can go to this cell. So go to simply this cell. When I say go to, simply add in the sum and simply get its count increased by 1. And again I can go to check that if I can go in the right, I can simply go in the right. Now I'll check for the next neighbor. Just simply saying if j plus 1 is less than n, just simply add its sum and count increase. I'll go on to the previous neighbor. But for the previous neighbor, you know that you will get its actual value from the current row. So I got its actual value from the current row itself, because I cannot use my image, because image has been modified so far. right? Okay, cool. And then I'll go on to the current cell, which is for sure current cell, which is the cell itself, current cell. So I just got go on to the current cell. That's great. I will go on to my top neighbors the same way I went on to my bottom neighbors. Exactly the same code, exactly the same code. You will see I went on to my top neighbors, simply saying, now for the top neighbors, I know I will use my previous row, because previous row is containing the original values. It is I minus 1 comma j minus 1, I minus 1 comma j, and I minus 1 comma j plus 1. Same, I minus 1 comma j minus 1, I minus 1 comma j, and I minus 1 comma j plus 1. I'll go on all these three values, same as what we did for bottom. It's just that we'll now use previous row as to get the original values, and ultimately I will have my modified values, which means sum upon count, and then I'll simply assign that to my image of I, and I can simply keep on going forward. Just make sure that as you go on to the next row, please assign your previous row to the current row, because these two rows are containing the original values. And with this, your space and time is O of, like, your time is O of m into n, which is constant for sure, like which will remain as it is, because you are not modifying that. Your space has reduced because now you are using only two rows. Again, the follow for you guys is just to use, again, for this I'm using a space of n into 2 because I'm using two rows. You will use only one row and one variable to get the answer. Now, the final method, which is actually more optimized, is because we will try to optimize it much more. How to even think of optimizing? Just think of everything which the interviewer has told you. Interviewer must have also told you the constraints. If you go and look for, then okay, m and n, that is pretty small, which makes this question easy. But let's say if m and n would have been pretty large, the thing which should click our mind is this value. Why the fuck is this value so small? As in, why he has given the value so small? Can I use the so small value? If you look this value closely, it is a 255, which is nothing but a 2 raised to the power 8 minus 1, because 2 raised to the power 8 is 256. That's a standard number which we all know. It's a number. It's a number which is 2 raised to the power 8 minus 1. Now minus 1 is just indicates 1. I have some zeros. Minus 1 will give me all values which has 1. That is, so it will be, if I say I have 8 values as 1 in binary, 1 in binary form, that number is at 255. That is what I have written also here, which means an integer value is a 32-bit number, but here I am only an integer. Again, an integer value is, if you just have remembered an integer value which is like you have written like 2 raised to 32 minus 1 in your like limits when you have studied your C language or any basic language, you must have written that integer bounds are this values. So you will see that you have the range of 32. You actually have 32 bits to place a number, but here I am only using 8 bits, which means remaining 24 bits are not used at all. That is the crux of this question, that you can use those extra bits to store extra values, which means I can represent my normal integer as these 32 bits. But what I will see is, if I just use this image of I comma j, which is just maximum value is 255, it will only use the starting 8 bits, which means this remaining 24 bits I can use to place any values in this, which means I can use this next 8 bits. I can use these next 8 bits. I can use this next 8 bits to place any other value. I can use this next 8 bits to place any other value. I can use this next 8 bits to place any other value. So basically, in this one value, I can place 4 different values, and they will not impact each other because all of them will be of 8 bits max. So there's other thing which you got to know, that in this one integer I can store 4 different integers, and I can retrieve all those 4 different integers anytime I want. So now you know that okay, the only issue which you had was you had to make another array to store the original values, right? So what I will do is I will not use another array. I'll use the same integer to store both the smoothen value and also the original value. The original value I will store in the start 8 bits. The smoothen value I will store in the next 8 bits. And again, if you want to have other variables also, let's say smoothen 2, smoothen 3, then you could have also placed them in the next 8 bits and next 8 bits. So this integer gave me options to store 4 different integers. That's how I can place it. So what I will do is I'll just use the starting 8 bits for the actual image values and the next 8 bits for the smoothen values. Now how we can do it? So one thing is for sure, if I give you a value, let's say 5, which is the image value, so it is 101, it is 101, but I will for sure store the 8 bits for the image of I. Even if it is a 00000, I will still store this value, which is like for the image of I, I'll still store the 8 bits. So I can just grab these 8 bits and say, okay, this is my value. And I said, so smoothen value. Now smoothen value is sum upon the count. Let's say if I have got the sum upon count as, let's say, number 7. So I know the 7 can be represented as 111. So now I know, okay, I have to place my 111 8 bits from starting. I cannot place it here. I have to, if this is the value of sum upon count, I have to place this value. I have to place this 111 value in after this 8 bits. So I'll place this 8 bits like this. And again, remaining bits for by default will always be 0. But make sure you are not using the starting 8 bits. But bhaiya, how to do that? Simple. Firstly, get this value as 7 and then simply left shift this 7 8 times. So what I mean is, firstly get this value as 7 and then left shift as in shift left. Okay, shift this left 8 times, 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 shift this left 8 times. That is how a left shift works. So this value, which means I will do a 7 left shift by 8. So this value 7 will be left shifted by 8 times to the left. And that's how you will be able to place your smoothen the value in the next 8 bits. But bhaiya, okay, this was the image value and this was the smoothen value which we have got. But ultimately I wanted to store both the values in one value, right? Yeah, simple. Okay, you have these values, you have these values, simply do OR operation. So what we'll do with the OR operation? OR operation, your image values will come in the left side because it is all zeros, so it will come as 101, and your smoothen value will come on this side, which is 111. Simply by the OR operation you will get both the values for us. So now in this one integer you have corresponding both the values, which is the actual value and the smoothen value, right? And smoothen value you achieved by getting the sum upon count, which is a smoothen value, left shifting 8 times, because 8 times, 8 times is giving me because of this thing, that I have this value as 255, which is a 8-bit integer. So my image value will take only 8 bits. Remaining bits are free for me, so I can just left shift completely by 8 and I will be safe at every moment and any moment. Now great. Now bhaiya, okay, my everything is done, my entire computation is done. I have used my original values to compute every of the smoothen values, but ultimately my value looks something like this. So my value will look as 111101. So if I convert this thing into an integer, so it will become as 11100000101, which is actually a different integer. I just wanted this smoothen value ultimately in the end. I don't want these values, right? So yeah, simply that's correct. You have this value. How you achieve that? By left shifting by 8 times. Yeah, so you have to remove this. Now simply right shift this value by 8 times. So you know that this is the value which you have. If you keep on right shifting, now how right shifting work is, if this is a value, it will just truncate. It will just truncate it, it will just leave ahead. So if I have this value, if I right shift this with 1 time, so how it will look like is, it will become a 111 and 10. So 1 got truncated, and similarly I'll keep on right shifting this entire value 8 times. So ultimately this thing will come to the end, and this will entirely truncate to the, like, it will just go away, it will just truncate, and this is how you will get the smoothen the values. Right? So that is a bit manipulation, great technique which the interviewer can ask you, and that is what makes this problem a medium problem. So again, everything exactly same as what we wrote in the above code. If we just go back, you will see everything. You will see. Just have a glance at this code. Have a glance. Everything will be exactly same. Everything. It's just that while I am assigning in my sum, I need to know that in my sum I am taking only the original values. I am taking only the original values. In my smoothen the values, I should know, okay, it should be my smoothen the values, right? Ultimately, I need to convert this values, which is a mix of smoothened and original values, to just only the smoothened values. So I'll just have a bit modification code here in the end, which will convert smoothened plus original to only smoothen the values by just simply doing a right shift. Let's quickly see that what we saw above. As I showed you, exactly same code. I went on to all of the ij, I went on to grab the sum and the count, I went on to all these 9 cells, I checked if that specific cell is in the bound of my entire matrix. Now if it is the bound of my entire matrix, I will go and say, okay, for that specific image value, just only get the original value. Original value is in the starting 8 parts. Now bhaiya, why is this value done? So you remembered that your original value, if this is a value, your original value was in the starting 8 parts, right? So you have this as the current image value, because you will be doing or operation, all that stuff. So your current image value is like this, will look something like this. You want only the starting values, because starting values represent your original values. So you will do a 1 1 1 1 1 1 1, remaining by default every one will be a 0. If you do a AND operation between this current image value and this specific mask, let's name it as mask, so this will give you all the values as what were the yellow values, and remaining everything, no matter if it is a 1 or a 0, remaining everything will be a 0. So by this you will get a original value only from this mixture of smoothened and image values, because right now image of I comma j, which is the input array, you have modified this to a mixture of smoothened and actual image, smoothened and original values, but you only have to derive the original values so as to add in your sum. So that's the same thing I did. I just make a mask of 1 1 1 1 1 8 times, and that ultimately I have just got this mask. I'll do an AND operation from this. It is the original plus smoothened, and this is the original value. This is actually the mask for original value only. When this is applied, so smoothened value entirely will be gone. I'll only get the original value out of it. Now when I've got the original value, I'll just add that in my sum and increase my count. Now by this I will only get the original value sum. Now when I have got the original value sum, I know that it is the sum, it is the count. From this sum and count, I can ultimately grab the smoothened value. Okay, from the sum and count, I can get the smoothened value. Smoothened value is sum upon count, right? Okay, I know that my image of I comma j was storing the original values. I have got the smoothened values. Now I have to add in this image of I comma j, which was only having original values previously. I just have to add in the smoothened value also. So just simply as I showed you, it is the smoothened value. Left shift this by 8 times, and then simply do a OR operation in the original values to make this original value as original plus smoothened values. So now this image of I will be having original plus smoothened values. But bhaiya, previously you were grabbing original values and you were saying that original values were having original plus smoothened. Yeah bro, exactly, because it will go on as we showed. If this was a matrix, this was the entire thing. So this is I comma j. So this is having these 4 will have original plus smoothened values in image of I comma j, and these 5 will have only the original values. And right now I am only modifying this specific cell which is having original values to original plus smoothened values to go ahead. That is the reason for this case. I did this, and for sure even if I do this for original also, it will only grab the original values because it is just removing the smoothened values. This case is only removing the smoothened values from my image of I comma j, right? And ultimately, as I have grabbed the entire smoothened value, like smooth values, sum upon count, I have grabbed the sum, I have grabbed the count. Now I can just add, like assign my smoothened value in my sum and the count. And ultimately I know that this now image which was earlier smoothened, which was earlier only original, now it has original plus smoothened values both. Starting 8 bits original values, next 8 bits smoothened values. Now ultimately my entire stuff is done. Now my image of I comma j, all the image of I comma j is having both original plus smoothen values. Original in the starting 8 bits, smoothen in the next 8 bits. But I want to remove all of these original values now. I only want to have the smoothen values. So I'll just simply do a right shift of every of the image values to only get the smoothened values. And ultimately I'll return the smoothened matrix sum. Like I'll return the smoothened matrix. And with this, you will use only O of 1 space, and time is again, it will remain same, which is actually O of m into n. And that's how incrementally we saw all the variations from very start to very end. That's the only thing which I wanted to show you. Incrementally go ahead in an interview. That is what makes him show that okay, you have not done a rectification and you have not reached your solution just like as it is. Cool. I hope that you guys got it. Bye bye. And yeah, please let me know that how this can be solved. That's an issue which has occurred a lot, and I just wanted to get this issue done. Cool. Bye bye. Thank you.